kind of quick because we lost time with the tornado drill. Make sure it's still pointed right. There we go. Okay. Backing up for 1 second just for the sake of the video.
Yeah, that's what I got.
Yep, alright.
It's just I didn't separate it.
If you are watching this video and you are absent today, please make sure you walk through the warm-up. So click on the problem, work through it. It's a great Taylor series problem. It's work through number 6. It's going to pull up an AP exam, do number 6, and then look at the solution, and then talk to me if you have questions. All right, today is 10.3b, concavity, arc length, and surface area with parametric equations. Quick review. When you take your first derivative, it's just dy dt over dx dt. That simplifies it to dy dx.
3 over 14.
If you take the second derivative, you differentiate the first derivative with respect to t and then divide by dx dt. When you take the third derivative, you differentiate the second derivative with respect to t and divide by dx dt. Alright. Okay, so we're working on this one. So you have your dx dt is 2t, your dy dt is 2t plus 3t squared. Divide them and you get 2 plus 3t over 2 if you cancel a t, right? So you end up with that for your first derivative. Your second derivative then is 3/2 divided by dx dt, which is 2t, so you end up with 3 over 4t. Is that okay? Questions on that? Is that okay? Okay. Alright. Yes? Alright. So now our only critical number is 0. So we put 0 on our sign line, and then we plug into the second derivative, right? We're determining concavity. So we plug into the second derivative. The function is concave down for all negative t values of t and concave up for all positive values of t.
Do you still need to justify?
Yes. Yes. Oh, and you know what? I didn't, did I? Oh, this is so bad. Okay, so this one, because d squared y dx squared is less than 0, would be your justification for why it's concave down. And this one, because the second derivative is greater than 0, would be your justification for concave up. Thank you for pointing that out to me, and I will add that.
Way to go, bro.
Okay. All right. Good. All right, try one more.
Sigma.
This phrase,
Yes.
what's the highest level math course that you think
It would have been real analysis.
simplify
Well, yeah, because at that point you've taken all of the math out.
All of the
math.
fake
It
analysis.
was,
All just
it was,
English.
Just letters, yeah.
Yep.
Sentence structure.
it was an 8,000 level course.
What?
Damn.
We have ratings for math courses and
So it's just a,
what are we at? Yeah.
yeah, when you're an undergrad, basically the numbers for all courses kind of equate with the year that you're in. Like 1,000 would be freshman level, 2,000 would be sophomore level, and so forth.
So
right?
basically, you were in college for 8 years?
We're at like 40.
No, I wasn't. But when I got my master's, I had to take a bunch of master's or higher level math courses, and that was the one that fit in my schedule well, so I took it. So that was one of them.
You know, real analysis
I
sounds
loved
so
it
simple.
because of my professor. Oh, he was awesome.
Otherwise, it was awful.
I think I talked about it actually.
Oh,
yeah.
Yeah.
This would be a 1,000 level. Yes. Yes. Yeah, of course. This might be a 2,000 level.
Wow, we're basically college sophomore guys.
It kind of would depend on what your degree is.
Yeah, no, the courses are assigned. Has
Well,
nothing to do
no,
with
I know, but my point is that your whole scale kind of corresponds freshman.
Oh, that's true.
Because if you're in
Yep.
engineering,
If you take it as a freshman, right.
So,
Okay. So.
but I multiplied by dt over dx.
Shouldn't that be a
Good. And then you just go like that. So your second derivative, okay, it's the first, the derivative of the first derivative divided by dx. So it's not the same thing. Yeah, but just do, what you don't wanna do, you have dx dt, so that's why we divide by dx dt.
Always on here now.
Yes.
Always on here now. Oh, okay.
Uh-huh. Perfect. Yeah. And then you make your sign line. Yes, that's exactly right. So yeah, that's the big thing was you had times and divided by. Okay. So dx dt is 2t, dy dt is 1 over t. So dy dx is 1 over t over 2t, or 1 over 2t squared. Alright, second derivative is the derivative of the first derivative divided by dx dt. Right? If you forget, you could do this, if this helps, right? So d dx of dy dx, right, is d dx of 1 over 2t squared, right? Okay, so 2t squared, or 1 over 2t squared, that's the same thing as 1/2 t to the negative second. So you end up with negative t to the negative third times dt dx, right? And that's how you end up with, you get your negative 1 over t to the third, and it's, when you do times dt dx, it's the same thing as divided by dx dt, right? Times dt dx is the same as divided by dx dt. So that's how you get it. I don't know if that helps you or not, but that's how you end up with that divided by dx dt for each subsequent derivative. Okay. So, second derivative is always negative, so the curve is concave down for 0 to infinity. Whoa, why not include all the negative values of t? Where'd they go? Yes, Paul?
This ln of t, you can't have.
Beautiful. First answer out of the box, yes. So, yeah, the domain of ln t is restricted to only positive values of t, so the answer would have to be restricted as well.
Is there any particular reason why natural logs are always positive?
Yes, there is.
Oh.
But I don't have time to teach you now, but I will show you after we're done with the lesson.
Oh, okay.
Okay. All right. So, you do not have to write this.
This image always scares me. I know there's something I'm not gonna understand.
You'll get all this. This isn't bad. You don't have to write this because this whole slide is actually, literally, I copied it and pasted it from chapter 7. This is just a review from chapter 7. And I'm gonna, it just leads into what we're doing today. It doesn't explain. So, arc length. Back in chapter 7, when we derived the formula for arc length, so we have, say we want to find the length of this arc from like 0 to 2, right? So you break it into segments. Just like when we found area, we broke into rectangles, right? Okay, so you break it into little individual segments. So the horizontal component of that segment would be delta x, and the vertical component would be delta y. So if we wanted the length of one of these little segment chunks, we would just use Pythagorean theorem with the side lengths of delta x and delta y. So there's the approximate length of a single arc. It's not an exact, it's approximate, right? Okay, so root delta x squared plus delta y squared. Now, in the past, when we were doing this with non-parametrics, just regular old functions, we would factor a delta x square root of delta x squared out. And you put that up front, and then so you divide everything inside by square root of delta x squared, and you end up with this. Now, delta x is just some generic distance between two random x values. It's just the width between two random x values. If we want to make this, take it from approximate to exact, then we need that width to approach 0, right? So what makes the width approach 0? That's where your d comes in, right? So dx is the same as delta x, except it's the limit as delta x approaches 0, right? So now what we've done is we've taken this big arc and found the length of this big arc, and we've used the same formula, except this formula gives us the length of a really, really tiny arc, right? Like really tiny. Okay. So tiny it's like a dot, right? Okay. So now this is the length of that dot, right? And of course, if we want the entire arc length, then we have to add all of the dots together. So we use an integral to add them all together, right? So that's how you develop the formula for the traditional arc length that we used to use. So integral a to b square root of 1 plus f prime squared dx, right? You all remember that like it was yesterday. Good. We're going to do the same process today, but for parametrics. So we still start with our delta x, delta y, and we find the length of that single approximate segment using Pythagorean theorem. But instead of factoring a delta x out this time, we're just going to leave it in. And the reason is parametrics are not written in terms of x, they're written in terms of t, so we don't want a dx.
dx dt.
Okay, so we're going to take the limit as delta x approaches 0, and then our delta x becomes dx, our delta y becomes dy, and we have an equivalent formula just for a teeny, teeny, tiny arc. All right, but we need to have a t in there somewhere, right? So let's add in some dt's. So how do we do that? Well, we're going to both multiply and divide by dt. So if you multiply by dt over dt, you're not actually changing anything. So we keep the dt on top outside, and we put the dt on the bottom inside. Remember, dt is the same as the square root of dt squared, so we end up with this dx dt squared plus dy dt squared, and it all works out great, right? Okay, so now that would be the length of one little teeny arc, right? And then of course we need to have the sum of all of them. So arc length on parametric equations is that right there. It's the integral from a to b of the square root of dx dt squared plus dy dt squared. Yes?
Oh, when you take the limit as delta x equals 0, how come delta y changes to dy?
Oh, because delta y, what it actually is it's the y value at each of the x values, right? And it's the distance between those two y values. So as delta x approaches 0, delta y should also approach 0. If the function is discontinuous, then you have problems, right? That's why we don't differentiate. That's one of many, many reasons why there's no argument. Okay, so you've got your formula. We're going to find the arc length of the curve with the equations x equals t squared plus 1 and y equals 4t cubed plus 3 on the interval from -1 to 0. This is a good, solid, meaty integral. I want you to do it with no calculator.
Wait, no calculator.
Meaty.
All right? It's very possible on your test you might have a calculator for this. However, we all know that part of this is to prepare us for the AP exam, and we all know that you will be doing lots of integrals without a calculator on the AP exam. Why not practice now, right? Okay, so take a few minutes, set it up, integrate. Over the next 5 days, we're going to be referring back to chapter 8 a good number of times. Integrals.
Oh, my favorite.
Yeah. This one actually though isn't even chapter 8. This is more like chapter 4. It's just a new sub. But it's been a while since we've done a good solid U sub.
It's been a good minute.
Yep.
Plus it's a u sub on a definite integral, so that's even more fun. I know.
Oh.
You do tricks out.
No, I just did u sub.
No.
That's not saying that
Oh,
you couldn't
yeah.
do trig sub, but I just did
It's a lot
it
easier.
straightforward. Yep.
You sub is hard.
12t squared squared
You did this part right.
I overheard something about it.
Oh, you squared the t. By the way, there's a little gotcha on this. Once you get your integral set up, you're going to be tempted to want to factor a 4t squared square root of 4t squared out, which is fine. But just be aware that when t is negative, I put a note on the board, the square root of t squared is not t, the square root of t squared is negative t.
Okay.
Just be aware. And I want you guys to do a proper u sub where you change your limits of integration.
Wait,
So this is a u sub.
Wait,
Yes.
why would you need to change?
why would you have to change the limit?
Yeah, it goes
Because
from
it's a
negative
u sub.
Oh, okay.
Oh, wait, okay, I'm sorry, I forget, because I just did it Mr. Thomas's way and ended up with.
Mr. Thomas's way now is to change the limits.
But that gets confusing, because now I don't know what to do. Like, I don't know how to do that right. I find it so much easier just to replace it right back with t.
I know, except that there's, ever so often, there's a problem in the AP exam that requires you to know how to do that. Like, it'll actually ask you what are the new limits, and so you have to be able to.
And I'll do it that way when I get to the
I
AP.
forgot how to do it.
Or you could learn now.
But this is already done.
All right, see if you get the right answer, and then we'll go back and I'll show you the other way.
Alright, well, I think I screwed something up. It wasn't for change.
You're stuck? Let me see.
Oh, wait, that's.
So Will and I did.
Good, is there a DT?
Yeah, I just did it.
Okay, and do we want to lose a point for not writing a DT?
Oh.
All right, good. Okay, so, there's, yeah, no mercy today. So this is the same thing as a square root, right? Okay, so do we have a GCF that we pull out?
I don't know.
So you need to, you're gonna factor a 4t squared out of each term. And then you have to, when you pull it out, you have to take the square root.
So yeah, you just have to make it bigger.
Except your Brian's gonna have to make it. Yeah. Yep, and then see if you can figure out what you have left.
She said you can.
You have to make it
She
negative.
said you could, she said you should.
Yeah, you said you'll be tempted to, but be careful, so you.
So wait, if she's saying that, does it mean we can do it without taking it out?
No, you can take it out, and t is less than.
You have to take it out.
You
Okay.
Yeah,
have to make it negative, it's less than zero.
you just have to make it negative. You have to take it out, you just have to make it negative.
Well, I got an answer, I just don't know how to simplify it. Oh, wait.
The answer is not
It's
pretty.
a triangle.
No.
Is it 8 root 2 minus 2048 over 93?
What's name?
I don't think so. Do you want me to take a
So
look
we
at
need
your
a
work?
72.
Well, my work is really dispersed kind of random, and I can't.
Negative 130.
Okay, what's 144
When you
divided?
pull the 2t out,
Yeah, because
how
Oh, yeah.
how did you get 2 and how did you get 31?
So it's a negative.
And then 144 divided by 4 is 36, right?
Oh, this is sorry. Negative 2t.
72, not 62.
Ah,
Yep.
okay,
That makes, alright, I'll see if this is.
okay.
How'd you get that?
Because if you plug in negative 1 and 0, if you plug in negative 1, so you get 37. But if you plug in a 0, you still only get a 1.
You know, you have paper right here.
6 times 2/3.
I don't, but okay, all right, that's
18
fine.
times 3.
So don't you want this work like so you can refer to it? Okay.
You get
Okay
negative
then.
172.
No, I got negative 1 over 24. because if you integrate, you go up to 3/2, but you have to put the 3/2 on the side. Yeah, you're supposed to integrate.
Yep, so that's correct.
Well, what did it
And
be?
that's- Yeah, perfect. You are on your way.
What'd you get?
-124.
What do you get?
So do you have, where's your, do you have it written somewhere?
I got 1 minus 37 over 37.
I think it's,
I'll give you a minute to kind of rewrite.
but you're you're dividing by 3/2, so you're multiplying by 2/3.
No, you're multiplying by 3/2. Oh, wait.
Oh, you know what? You're, when you found your lower limits, so you plugged a -1, it's actually 37, yeah. So it ends up actually being uglier than that.
You have to look at mentally stuff, so plug it in and see what you get. Like, I'm confused.
You got an answer yet, Kathleen?
I got 1 minus 37 for 37 and 54.
Very good.
That's not what I got.
Also, that gives me a negative number, which
Why'd you go from 37 to what?
How do we do the 37?
Because, why'd you change it?
Because it's a U
Correct, is that the answer? It's
Yeah.
plus 1.
I don't know if you're okay.
I didn't have to change it.
The interval
Yeah,
for
but
t is
two-thirds.
-1 to 0,
Negative
so
one
you
to
know
zero.
it's -1 to
Because you
0.
have to plug in the original limits into the U.
Like that. You know what's weird? Instead of your teacher this
At least, yeah, but. Got it.
Then you would probably just,
You
if
negative
you had
number
to
as well.
do this in an integral, then
Dude,
you
Mr. Madden split it. It didn't bump up Satish.
Okay, and then
And he had a 92.
which, I mean, you do an integral from
What'd you
-1
get?
to 0. Using your positive, so you're from negative.
What is it? Times U to the 3/2.
1 minus.
I'm surprised by that. We not have a calculator.
You would not have calculators, so let's see. No, it's not a beautiful, I mean, well, so who am I to discriminate against numbers, right? It's fun. So, anyway, is that what you got? Yeah. Fantastic.
Hold on, can I
Okay,
say?
Equivalent to correct is correct, right? So you can-
equivalent to correct is
how did
correct.
I mix
So like you don't
As
have to
U.
get rid of the
Negative.
little line.
You do, you have to evaluate.
Okay.
Oh,
Yeah.
we shouldn't have-
I mean, if you wanna say equivalent to correct, you could just say this is my answer,
Yeah, yeah.
right?
Yeah,
Okay.
because you see
No,
that,
it
you
has
should've-
to be,
you should've
you
just
have to have
corrected,
actually
confirmed it,
evaluated the
transfer it.
integral.
Aren't
And
there a
then
lot of
flip by
problems
getting
though,
rid of the
like,
negative.
on the well, like just where you can write the integral, like it asks for the integral.
There's some,
Yeah.
yeah, a lot of area volume questions are like that, they just
Yeah.
want the setup, yeah. So, and this could be, our point kind of goes in that territory, so this could be one where they just want the setup. But, in this, I want you to evaluate, so, did you all, if you have to rewrite using U sub, so my U, I let U equal 1 plus 36t², so du was 72t dt, right? So I replaced t dt with 1 over 72 du, right? And then so I got -2 times 1 over 72 du, u to the 1/2. To change your limits, if you write your integral in terms of u, just plug the -1, this is a t value, right? Plug it in for t and see what u is, right? So if t is -1, u is 37. If t is 0, u is 1. Oh no, we're high and low, right? So we want to flip the limits and make it positive. So I just flipped the limits and made it positive. And then it's just a standard antiderivative, right? So 2/3 u to the 3/2 from 1 to 37, and you're just plugging in. Questions? Yes, Troy?
Sorry, can you explain again why you got the -2t?
Oh, okay, so we knew we needed to pull a square root of 4t² out, right? Okay, so the square root of 4t squared is equal to 2t if t is positive. But if t is negative, the square root of 4t squared is equal to negative 2t. Now let me give you an example, okay? Suppose t is negative 1, right? So if we had 2t and say t is negative 1, right? Then 2t would equal negative 2. But the square root of 4 times negative 1 squared would actually be equal to positive 2. They're not the same, right? So to make them the same, if t is negative, you have to multiply by a negative, and that way this will give you the same value.
So we use a negative because we had from -1 to 0.
Yes.
So what do you do if it's like -1 to like positive numbers? It's still.
I hope that that wouldn't happen, but if for some crazy reason it does,
Oh,
and if for some crazy reason you have to do this process on that, you'd have to split it.
Yeah, okay.
Yep.
College board.
Yep.
The college board is unfair.
All right. Okay, we're going to quickly derive the formula for surface area. Okay. So this, again, you don't have to write down, this is the old one. I'm going to, in a minute, show you the new one. Yes?
Do they have a history of hitting the trapezoid rule and stuff hard?
Yes. Not hard, but usually like one part of one problem per test.
Which is stupid.
Yeah, I know.
So anyway.
Yeah.
Gosh.
All right. Quiet down, please. All right. So, formula for the surface area of a cone is pi r squared plus pi r s. So, if we drop the base, which apparently is really funny to say. Okay.
I don't get it.
I don't either, but I third year was just cracking up. So anyway, if we drop the base, then we get what's called the lateral surface area, which is the surface area of the cone part without the circular bottom, right? So it's just pi r s. S is the slant height, right? That's S. So pi r s, surface area of the cone part of the cone. Okay. When we are doing surface area of a volume formed by revolution, we are actually adding together infinitely many conical frustrums. A frustrum is the portion of a cone with the top cut off. Alright? So the surface area of a frustrum is 2 pi rs, where big R is the average of the two radii. Alright, and S again is the slant. So if you look, I drew a really, this is old, I was doing this on, like with my mouse on the computer, so it's not a great drawing. But anyway, so if you have a curve, and you want to approximate the surface area with conical frustrums, right? If you take this cone, the frustrum, and turn it sideways, and then if you kind of picture like one of these sections being revolved around, what's this revolved around, right? You get this frustrum, right? These are a bunch of sideways frustrums. You add them together and you get the surface area for the whole thing. Whoa, whoops, I don't want to do that. Okay, all right, so anyway, okay. So, surface area, we figured out back in chapter 7, is 2 pi rs. Well, S, that slant height, the slant height is this like right here, which we just learned how to do by figuring out arc length, right? So, it's really just 2 pi r arc length. The r, the radius, when we are revolving about a horizontal axis, it's our y value, our function. And when we're revolving about a vertical axis, it's the x value. Technically, this is x-axis and y-axis, because remember, if you were revolving about something like x equals 10, it's actually 10 minus x is your r, right? That kind of a thing. We got into all of that back in chapter 7. Okay, so we loved arc length, or surface area, because we could do every single one of them with respect to x, which is nice. All right. So now, to write them in parametric form, blah, blah, r of x would just be our y of t equation when we're revolving about the x-axis, and our x of t equation when we revolve about the y-axis. So we end up with this.
You
So,
have 2 minutes, by the way.
surface area, oh, good, we can do this. Surface area is 2 pi y times the square, times the arc length, if it's an x-axis revolving, and 2 pi x times the arc length if you're revolving about the y-axis. Some people today got confused between the difference between x of t and x. They're the same thing. It's like writing, like when we write functions, if I write f or f of x, right? This is just, you can write x or you can write x of t. One just identifies your input variable and one doesn't, but they're the same thing. So when I say 2 pi times x of t is your x, right? So it would be t for this guy. And then y of t would be your 4 minus 2t. Okay, so I want you for, if nothing else, to at least set up your integrals for each of these before the bell rings. Those in video world, we had a tornado drill, that's why it's short.
It wasn't a drill.
There was an
This
actual
is the only
tornado.
room left standing.
Yep. This isn't an actual
video
tornado
running?
happened.
Oh, no, not at all. I didn't start talking.
Because that would have been really funny. That would be interesting.
You're gonna
You,
get
like,
a right?
Yeah, man.
just live
I'm gonna be.
podcast
My
your,
finger's gonna be
message.
famous.
You're not on there.
No, that's not.
You're still not on there, Brian. Oh, there you go. I think you got a little bit. You got a little bit.
That way if someone's sick, you know.
Okay, so how do we do with our setup? So about the x-axis, remember when you're going about the x-axis, you use your y value. And when you're going about the y-axis, you use your x.
The waxes.
Is everyone okay?
I like to rotate my
All right, fantastic. All right, so tonight, section 10.3b. Tomorrow we start polar. Brian.
Why didn't we